So for example, 17.5 part B, same instruction. Now, I know it says F inverse, F and F inverse in the instruction, and we're calling B G. So we'll just adapt the instructions for G and G inverse here. And we'll start with taking the equation, and we're going to write it as y equals x plus 2 raised to the third. That's step number one. Step number two is to then look at the graph of the function, verify that it is in fact a one-to-one function using the horizontal line test. This is going to be a cubic function shifted to the left by 2. I'm going to mark all of my points and attempt to graph a cubic function. Certainly not my best work, but it'll have to do. Because really the point here is for us to be able to identify whether or not it's a one-to-one function. That's the purpose of the plotting. It doesn't really serve much other purpose here other than to also make the observation later with G inverse, which we'll get to that. So this does pass the horizontal line test. It is a one-to-one function. Let's go ahead and switch the x and y. And when we do that, we're going to end up with the statement x equals y plus 2 raised to the third. I'm going to take the cube root of both sides to get the cube root of x is equal to y plus 2. Then I'll subtract 2 from both sides, saying that the cube root of x minus 2 is all equal to y. And that's what we can now use to call G inverse of x. Now G inverse of x is a cube root function that's been shifted down by 2. So let me start here down by 2, and let me recreate a cube root function best that I can. Call that G inverse. And the observation that we're always supposed to make is that the line y equals x should act as a line of reflection. And if there's any points of intersection, the graph should intersect on the line y equals x. And that's precisely what happens here. So another good example of a function and its inverse. And this is that procedure, again, where we replace the g of x with the y, switch the x and y, then we solve that equation for y, and then that equation becomes your g inverse.